Okay, so last time I showed you how to factor the number part of a monomial. This time we're going to look at the letter part, or factoring variables. So let's go ahead and start with this example right here. X to the fifth plus x to the third. Quick question, what's x to the fifth plus x to the third? I'll give you a second. Go ahead and pause. That's right. X to the fifth plus x to the third is x to the fifth plus x to the third. They have, in order to combine them, in order to add or subtract them, they have to have both the same base and the same power. These don't. These are two different things. So you cannot combine them. But what we do want to do is we want to factor them. And the way that you do this, you find, just like on letters, you find the greatest common factor. Well, this is actually pretty easy. You just look at the one with the smallest power. You factor that out. So that would be x to the third. That goes into both of these. Go ahead and set up your binomial. That's your monomial that comes out of both of these, factors out of both of these. That's a plus. Okay, now I have to ask myself, x to the third times what is x to the fifth? X to the third times what is x to the fifth? Do you know? Okay, if you don't, let me give you a real quick refresher. These are side notes. Whoops, these are side notes right here. So what if I had x to the fourth times x squared? Well, x to the fourth would be written like this. X times x times x times x. That's x to the fourth, right? Times at the same time as all these others. I'm just showing that these two are the same. Okay, and how do I write x squared? That's x times x. So how would you write where you multiply x times itself over and over and you see it 6 times? Well, that would be x to the, I see it 6 times, x to the sixth. So if you understand that's what's going on when you multiply variables with the same base, okay, then you don't really need the shortcut. And the shortcut is just this, x to the 4 plus 2. You add the powers, which is x to the sixth. All right, so knowing that, we should now be able to do this one right here. All right, so x to the third times what is x to the fifth? Well, it would be x to the 3 plus what is 5? 2. All right, so x to the third times x squared is x to the fifth. Now, x to the third times what is x to the third? Well, anything times what is itself? Anything times 1 is itself. There you go. So now, let's check it. X to the third times x squared is x to the fifth, and x to the third times 1 is x to the third. So there's the answer to that one. Okay? All right. Now, let's go ahead and give you an example for you to work on. So go ahead and pause it. Okay, I'm assuming that you pause it, and I'm going to show you how to do it. Let's start with, let's just go ahead and do our setup here. We know that it's going to look like something like this. That's a plus, so I'm going to put a plus right here. I'm going to start with the number part. So what's the greatest common factor of 9 and 12? If you know, great. If you don't, write out your factors and then find the greatest common factor. Well, the biggest number that goes into both 9 and 12 evenly is 3. So we're just going to do the number part of it. 3 times what is 9? 3. 3 times what is 12? 4. All right, so there's the number part of it. Now let's do the letter part of it. Again, you look for the smallest power. So x to the third goes into both of these. So x to the third times what is x to the seventh? In other words, 3 plus what is 7? It's 4. There we go. Now, x to the third times what is x to the third? Well, it's just 1. So if it's just 1, then you know 4 times 1. I'll go ahead and make it invisible here. Pretend that's an invisible 1, right? Well, 4 times 1 is just going to be 4. So the answer turns out to be just a simple 3x to the third times 3x to the fourth, plus 4. Let's check it. 3 times 3 times x to the third times x to the fourth is 9 times x to the seventh. 3 times 4 times x to the third is going to be 12x to the third. So if you know how to multiply monomial times a binomial, you know that that takes you from here to here. And that's how you check them. All right, we'll give you another example. All right, go ahead and pause it and then work on this one. Okay, I'm assuming that you did it. Again, we're going to end up with a monomial times a binomial. That's a minus this time, so let's put a minus in there. All right, let's start with the number part. What number goes into 5 and into 15? 5 goes into both. 5 times what is 5? It's an invisible 1, right? I'm going to put an invisible 1 there. Later I won't, but right now I'm going to. Okay, and 5 times what is 15? It's 3. There's the number part. All right, so now let's go ahead and do the letter part. Look for the one with the smallest power. Well, I've got an invisible 1 right here, right? Y to the 1 is just y. Okay, so y to the 1 comes out. That's a y to the invisible 1. Okay, so y to the 1 times what is y to the third? That would be y to the 1 plus what is 3? 2. Okay, and then y to the 1 times what is y to the 1? That's going to be an invisible 1, right? Okay, so now let's just clean all this up. 5y to the 1 is just 5y. Okay. 1y squared is just y squared. Whoops. Just y squared. Yikes. That's a 2. Okay. And then 3 times 1, even though it's an invisible 1, is 3. So now let's check it. 5 times y squared is 5y to the third. And 5 times 3 times y is 15y. So if you know how to multiply monomial times a binomial, again, you get here. All right, so there it is. If you have any questions, just go ahead and give me or let me know, and we'll go from there. Thank you.